Okay, for today we learn set theory in the mathematics discrete structure. Uh, a set is an ordered collection of different element. It is can be written explicitly by listing the element using the set of bracket. Okay, we can list the element. Element. This one contains the element that we can list the element using the bracket. Okay. Okay, and then it is a collection of definite and distinguishable objects selected by a mean of certain rule of description. For example, we can have a Venn diagram. Venn diagram here. Okay. And then we have a union, and then we have intersection, and so on. Okay. You need to have the distinguishable object, and then it uh, pertaining a certain rules. We are assigning a certain rule. Okay, the rules for the set. For the set. And then set theory form basis of several other fields study like counting theory, relation graph theory, and finite state machine. This one is the definition. Okay, set theory, a collection of object that contains the element. Element you can define in the bracket lah. Okay, and then for example, A is element of set A. This one is set A. This one is A lah. A is object lah. Okay, and then you can see it is the element, or you can see it is the member of A. It is equal. Both definition can be accepted lah. Okay, and then if you see that A is not element or member of set A, you can have a symbol like this. It's not the member, not a member of set A. And then set A contains the elements, from A1 until AN. And then for the set, the element or the element is meaningless. For example, if you have A, okay, you have A, B, C. Okay, you counted as three element. Three element because A is one, B is two, C is three. Lah. Okay, and it doesn't matter how often the same element is listed. Lah. Okay, so far do you have any question? Ada soalan ke? Haris, boleh ke? Okay, for example, if you have a group players in a football team, is a set. Lah. Okay, okay. Sometimes it called element, sometimes it called a member. You can have both definition. But most importantly is it is a set of collection of object or group of object. Okay, this one example for set. We have set A is the empty set. Okay, we have empty set. Okay, we can count it, or we can uh, draw as an empty set like this, or you can draw equivalent to empty set like this. Okay, empty set, or you can call it as a null set. And then if we see set A have one element only, Z, but Z is a member of A, set A, but Z is not equal to Z element. Yeah, it's not the same. Okay, because Z, if you draw Z like this, it is called the element. Element inside the set set of object lah. Okay, and then we have elements BC, CXD. Okay, and then Z, element Z is a member of set A, and then set A contains the element of Z, and then it is empty set or null set is not equal to uh, element of empty set. Okay, this one is not the same. Okay, okay, BC we can define as BC member of set A, and CXD is a member of set A also lah. We have two here. Okay, another one is A XY. Notes that XY is element of A, but XY is not seen by the, if you have two bracket here, it's not the same because it is the element inside the element. Okay, this contain both. Okay, both bracket. So that we can see Y is not a member of A, but XY is element of XY is member of A. Okay, and then in set A we have X, whereby the PX is the predicate. Okay, we can define set of all X such that PX, and then we have X. Okay, and then restriction, X is member of natural number. Okay, and then X must be greater than 7. So we can say that n from 0 until, okay, until n lah. And then from A we have from 8, 9, 10 until n lah. This one must be greater than 7. Okay, do you have any question? Is it okay? Okay, basically for the history, okay, it is created by George Cantor in 1845 until 1918. A German mathematician is initiated the concept of theory of set or set of theory. Okay, this one when he tried to solve the problem that called as trigonometric series, he encountered the set, okay, that become one of the most fundamental concept in mathematics. Okay, this one is theory origin of the set theory. Okay, then equality, set equality. We can define set A and set B are equal if and only if IFF they contain exactly the same element. For example, if we have set A is 9, 2, 7, -3, but the order is different, okay, we can define A is equal to B lah. Set A is equal to set B. Okay, but if we have a different member, for example, we have dog, cat, horse, okay, and then we have squirrel, and then we can have the conclusion set A is not same with set B. Okay, but if we have the order like I explained before, we have dog, cat, horse, and then we have cat, horse, and dog two times. Okay, we can also define as A, set A is same as set B. Boleh? Do you have any question? Ada soalan ke? Ada. Okay, saya explain lagi lah. So equality ni, for example, we have two set, okay, A and B. And then we have element here inside the element 1, 2, 3. 1, 2, 3. We can say set A is equal to B. Okay, but if the set A as for example set A only contain 1, 2, 3, we can see that set A is not equal to set B lah. Okay, because the element. Okay, this one example for set. We have a standard. Standard mean that you need to comply. N is for natural number, and then we have integers. Okay, integers contains negative and negative numbers. Okay, and then we have positive integers, z plus for positive integers. If you want to define the negative integers, z minus lah. And then we have rational numbers and real numbers. Real numbers and rational numbers. Okay. Rational numbers is the subset of real numbers. Okay, like this. Okay, this one is real numbers. Okay, then we have rational numbers and then we have integers. Okay, for the rational numbers, dominator, okay, let's say 1 is divided by the integers. Both must be integers, but the denominator must not be equal to 0. This one is the definition for rational numbers. Okay, okay, in mathematics, a rational number is a number that can be expressed as a quotient or fraction of a divided by b. Okay, of two integers, a is numerator and b a non-zero denominator. Okay, for example, we have negative, sorry, negative 3 divided by 7. Okay, this one is rational number because this one is integer. This one also integer. Okay, as I mentioned before, we have rational number uh, is a subset of real numbers, and then integers are subset of rational numbers. Okay, for example here, another example, we have A set A, B C, okay, and then we have C X D, okay, and then we can see that B C is an element of A and C X D is also element of A, but B itself is not a member of A, okay, because uh, B itself is the element, element inside the E. Okay, for example, if we have B like this, you can say B is a member of set A. But if you perceive, let's say C is not also not a member of A, okay, you have the element. You must define the element inside the set. Therefore, you can have a conclusion that B is a member of set A. Okay, this one you must bear in mind. Okay, this one. Okay, this one. Hafiz, boleh Hafiz? Mama Hafiz? Hafiz, ada ke? Hafiz dia main game kot. Okay. Okay, this one example of set. We have to define the rational numbers Q. Okay, we have A, B. A is integer and must divided by the denominator. Numerator divided by the denominator is not equal to 0. Okay. Okay, we can define as A divided by B. We can have A is member of Z, set Z, and B is element of integers, positive integers. Okay, this one is positive integer. Okay, okay, or you can see that A divided by B, A is member of Z, and B also member of Z, and B is not equal to 0. And how about the set of real number? Okay, if we have R, and then R is the uh, element inside the rational number, and R you define as a real number. Okay, this one example. We have a rational number. Okay, Q A divided by B, and A is a member of integer, and B also member of integer, but B is not equal to 0. And then is it 2? The question is it 2 is the member of, is it 2 is a member of Q? The answer is yes lah. Is it negative 2 is a member of rational number? Yes, because you can say 2 equal to 2 divided by 1, negative 2 divided by 1. Is it 1.5 is a rational number? Yes lah, because 1.5 we can divide 3 divided by 2 lah. And then is it 0.33 is a rational number? Yes lah, because it is 1 divided by 3. This one integers. The denominator also integers lah. Okay, and then the power of 2, is it the rational number? Okay, it's not the rational number lah, because the estimation is 1.142 is a real number. Also seen by the power of 5. What is the value of the power of 5? Apa dia punya value dia? Hmm. 2.2360. Eh? Okay, this one is not a rational number. It is a real number. Okay. Di atas daripada rational number. It's above from the rational number because because the rational number is subset of real numbers. Okay, this one for the Venn diagram I have explained. Okay, okay, we have integers, positive integers, integers, and zero is a subset of q, rational number, and rational number is subset of real numbers. Okay, and then we have a subset. A we can call it a subset. Subset of B. If and only if every element of A is also element of B. We can also formalize by using A subset of B is equal to for all X, and then X is a member of set A, and then X also a member of set B. For example, we have A 39, we have B 5913. Is A is subset of a B? True, lah. Okay, because we have 3 and 9. Okay, we have 3 and 9 here. Okay, 3 and 9. Is it B is a subset of A? The answer is false. Ya, ada nak tanya ke? Okay, B is false because uh, the B element is not fully in the A element. As you can see, okay, we have 5913. 5 and 1 is not in element of A. That's why we cannot see that B set B is a subset of set A. False. Okay, same goes to number 2. Okay, we have 339 and then B 5913. Is it A subset of B? True. Is it B subset of set A? The answer is false because not all element in B have in A. No? Okay, and then is it A subset of B? The answer is false because 1 is not in the B. Okay, do you have any question? Ada nak tanya ke? Ada. Okay, a subset is as the name suggest, it is a sub collection of any set. Okay, for example, uh, we have two set x and y. Okay, and then mathematically speaking, that x will be subset of y, if and only if all the element of X are presented in Y lah. We can also say that X is contained in Y. That sometimes the relationship is called inclusion of or containment of X in Y lah. Okay, for example, in here we have A subset of B. We can see is any set of A is inclusion, or we can call it as containment of set A in B. Okay, inclusion of set A in B, containment set A in B. Okay, meaning to say that all of the sub collection of any set. Okay, okay, you all cuba buat exercise ni untuk subset. Kalau ada yang tak clear lagi. Okay, determine whether set A is yep, is a subset of B. Yang A okay, Fatin aja boleh tolong jawab ke macam mana? Is it A is subset of B? Fatin? Why? Okay. Okay, if I ask, is it B is subset of A? 13? Okay. Okay. Because again, if we see here, A is inclusion of set B lah. Okay, true lah. Is subset lah. Subset or this one is equal sign. Okay, inclusion or containment from inclusion set A to set B. Okay, inclusion. It is clear that from analyzing of two set A and B, that A element belong to set B, so A is a subset of A lah. Okay, that what is the answer. Okay, if I say determine also same, but this one tertukar sikit lah. A is sedan, D is cars lah. Najmi, is it A is subset of B? Najmi boleh tolong jawab? Najmi mana Najmi? Ada ke? Macam mana apa jawapannya? Is it A is subset of B? Senangnya soalannya. Sedan, kereta sedan. Yes lah, Nabila. Why, Nabila? Yeah, I know. Set B is the cars. Include all type of cars lah, including the sedan. We have apa lagi? Kereta, apa lagi jenis kereta? We have sedan, we have hatchback, we have pickup, we have pickup truck, we have MPVs, and then we have SUVs, and then we have electric cars. Okay, and then dia adalah subset of B lah. Okay, therefore A is we can define as a subset of B because all element of A are included in B. Okay, all element in A is included in B. Okay, Ainun boleh Ainun? Ainun Syakina. Kamu main game tak? Ke tengah masak-masak? Okay, subset this one you can see clearer. A set A is equal to B is equivalent to A is subset of B and B is subset of A lah. Okay, we can see in the Venn diagram when you say that B is a subset of A. Okay, we have B. Okay, all the element in A is inclusion of B lah. And then BA is a subset of C. All the element in B and A is the containment of C in C. Ada dalam C. Okay, class. I think we rest for 5 minutes.